Hello, folks. I hope you can hear me. It looks like all of a sudden my background music is not playing, and I don't know why that is. There's always got to be these strange problems. Let me make sure that the stream is going smoothly. It looks like it might be, but let me see if I can fix up this background music real quick. Uh, Long time no see. Long time no see indeed. Background music. Come on. Can't we just have this go smoothly? Background music doesn't look like it's gonna play, and now my different visual elements are like disappearing. Oh well, come on. This is how it goes with the live streams. They always stress me out because stuff never works quite the way you want it to. Okay, as long as you can hear my voice, hopefully you can forgive the background music not working properly. Let me try one more time to connect it. Let me know how you guys are doing this evening, and if you have any math questions, although I've got a couple in particular that I am looking to work out in just a minute here, if I can find my background music. Oh, you know what happened? My hard drive that has all of my live stream files seems to have disconnected. Wonderful. Okay, let me see. Let me just try to unplug it and plug it back in. Of course, as soon as I start the stream, this happens. As soon as I start the stream. Unplug it, plug it back in. I'm sure that'll cause some catastrophic problem. But maybe not. Maybe it'll work. It's been a while since I did a math and chill live stream. As always, just going to do a little bit of math tonight. I don't know how long I'll hang out. But if you got any questions, math questions or otherwise, feel free to let me know, and maybe I can help you out. The last time I did a stream was in May, and it's been a while, but before I blab too much about that, let me just get into some math. Let me know if the audio levels seem a little wonky, if my voice is too loud, or if you can hear a bunch of crickets. My window is open right now, so if you can hear a bunch of crickets, that's why, and if it's annoying, I can go close my window. But no time to waste. Let's hop right on over to the math cam to do some math, because there's some math I'd like to quickly explain, just to have my explanation sort of on file. Let's see. And again, if you guys have any questions, math or otherwise, feel free to interrupt my ramblings about a couple Algebra 2 problems, although my head hasn't been in like graph theory for a little while. So if you want to talk graph theory, just be warned, I'm rusty, so don't get your hopes up. But let's see. I have my Algebra 2 textbook right next to me here. It's, the classic Larson with the pair of sprinters on the front. And there are a couple weird little exercises here about properties of real numbers, the properties of real number operations that I want to quickly work through. The first couple are very straightforward. All we've got is some examples of these operations in action, like, for example, 4 plus 9 in parentheses plus 3 equals 4 plus 9 plus 3 in parentheses. So this part of the book gives us a few things like that and asks us what property is being applied there, or what property we see in action in this expression. Why is this sum equal to this sum? And the answer is the associative property of addition, which tells us it doesn't matter how you associate a pair of numbers when you've got 3 being added. We can associate these, 4 and 9, in parentheses, or we can associate these, 9 and 3, in parentheses, and either way, we're going to get the same thing. These things are equal, and that's by associativity. Knowing these handy-dandy properties of the real numbers allows us to kind of avoid making mistakes and allows us to chug on and simplify and work with expressions when we know what we are allowed to do. Another quick example would be 5 plus negative 5 equals 0. What's going on there? What property do we see in action? Let me take my inaugural sip of Sleepy Time tea here. The property is very simple. It's the definition of an inverse. We say that real numbers have additive inverses. So given any number, like 5, there's some number that we denote negative 5, so that when you add them together, you get 0. So this is just an example of an additive inverse, which I'll write in yellow. I will not write in yellow, because yellow is completely impossible to see. Let me write it in dark green. Additive inverse. And again, if you guys got any non-Algebra 2 questions, feel free to let me know. I'm just working through a couple of these. Additive inverses. Now, just looking at a couple of these properties, with the basic properties of real numbers in mind and their operations, we can justify seemingly inane statements that you wouldn't normally expect yourself to have to justify, but going through the process of doing so is good practice. So let's see. 6. Let's do this one. 6 multiplied by a divided by 3. 6 multiplied by a divided by 3 equals 2a. And what we want to do is just explain step by step why this is true. Why is 6 times a divided by 3 equal to 2a? You have to understand how multiplication works with grouping, with parentheses, and you got to understand how division is defined. And then we can work this out, no problem. What you want to understand about division is that when we divide, like a divided by 3, that's the same as multiplying by the reciprocal of 3, because that's how we define division. So if you want to show that this is equal to this, we want to start on the left side and apply the properties of operations on real numbers that we know in order to get to the right side. So if I write in a different color, because writing in a different color is nice, I'd start with what's on the left, 6 multiplied by a divided by 3. And then I'm going to point out that this is the same as 6 times a multiplied by 1/3. And again, that's by the definition of division. A divided by 3, that means we're multiplying by the reciprocal or the multiplicative inverse of 3. So here, to justify what I just wrote, I would write definition of division, or if you wanted to be kind of lazy, you could just write definition of the division symbol. There you go. And now you're pretty much home free. That's really the biggest change you have to make. To finish this off, all you want to do is use the associativity of multiplication and the commutativity. If we use, and what you want to notice here is that we're trying to get to 2a. We have a 6 and a 1/3. And so we see if we can bind those with multiplication, we're going to get the 2 that we're looking for. It's just a matter of doing that in the correct manner. If we want to combine the 6 and the 1/3 through multiplication, we need to get the 1/3 next to the 6. In order to do that, we need to swap these numbers around in the product. So then, can we swap those numbers around? And the answer is yes, of course we can, by commutativity, as they say. So multiplication commutes. So we can write this as 6 times 1/3 times a. And this is by commutativity of multiplication. Order doesn't matter with multiplication. So I can commute or switch the 1/3 and the A. So I'm just going to write commutativity. You really got to sound that word out because of all the T's in there and the I's. It gets a little tricky. Commutativity lets us switch the order of the multiplication. Now all we need to combine the 6 with the 1/3 is associativity. So I can say, instead of combining 1/3 with A right off the bat, I'm going to combine 6 with 1/3 by associativity. So it doesn't matter how I group the multiplication. 6 times 1/3 times A. And this is a result of associativity. Aviso says, nice. Thank you, Aviso. I don't recognize your username. I appreciate the nice. It's a nice problem. I'm surprised to see some of this sort of rigorous stuff in an Algebra 2 textbook because it's been so long since I took Algebra 2. But I suppose it makes some amount of sense because in most geometry classes you would have done some proofs. And so now we're sort of applying proofs to our basic operations using the properties that we kind of take for granted in an Algebra 2 course. Again, if anyone's got any questions about anything, this stuff or otherwise, feel free to shoot and see if I can help. Maybe, maybe not. I'm kind of tired, so, I've just been doing math all day, so my brain is not at maximum capacity, but I still have some juice left. That's why I'm here. Which is also why I'm having my sleepy time tea. Got to get the juice a little lower so that I'm able to sleep at night. Okay. I probably should have finished my word on notability here before I stopped writing. Associativity. That's what we were going for. Associativity. So that's why we can group the multiplication however we please. So instead of 1/3 times A, we have 6 times 1/3. Now we're there. 6 times 1/3 is 2. And so this is equal to 2 times A. Bada bing, bada boom. It's a little long-winded, but I think it's pretty easy once you get the hang of it. Verifying that this is true using the properties of real numbers. You kind of want to be at a point when you're in Algebra 2 that you look at this, 6 times A divided by 3, and you pretty immediately do what we just did in your head or quickly on paper. You say, okay, A divided by 3, that's A times 1/3. 1/3 times 6 is 2. Okay, it's 2A. But these are the steps and why they work. So if we do another example, which we will, let's say we want to prove, let me look at my text here. Here's an easy one. C minus 3. We want to prove that C minus 3 plus 3 equals C. You can't get much more instinctually obvious than that. I think this is pretty much one step. So all we have to do here, I got my comments here on my phone. CC, I recognize you, CC. I feel like it's been so long because it's been so long since I did a live stream. Are you teaching an Algebra 2 class? Yes, I am teaching an Algebra 2 class, and I assigned some homework today, which after looking at it, I was like, I don't think I quite covered what I should have covered for this homework. We talked about the properties of the real numbers and the operations, but I think I should have done an example of this since it was in the homework. So I think I'm gonna hear from them tomorrow unhappy things that they're not super that they weren't in love with the homework assignment. So I'm just doing a quick explanation here for posterity in case I want to use it. But again, any folks here in the stream, if you got any questions, let me know. Just working through a couple of these Algebra 2 problems, and maybe I'll move on to some other stuff after in 10 minutes or something, or maybe I'll just go to bed. I'm not sure. But let me know if you have any questions or any thoughts. Always happy to have you guys here. CC asks, are you still working as an actuary as well? Good question. No. I've been kind of meaning to do a video for a while, talking about my transition of quitting my job, but I haven't felt like it. And by haven't felt like it, I mean I've been way too busy. So, no, I'm not working as an actuary. I liked teaching you guys through my camera too much, so I quit and decided to go teach some real humans in person. Yeah, maybe we can talk more about that another time in a video or something. But that's what's going on. C minus 3 plus 3 equals C. How are we going to do that? Well. The first thing we should do, we kind of want to use associativity here. And let me rewrite the problem. So we start on the left, C minus 3 plus 3, and we're going to work to get to C. We kind of want to use associativity here because we want to combine the negative 3 and the 3 to get our 0. However, all we know is that addition is commutative, and right now, all we know is that addition is associative. It is also commutative, but that's not the point. Addition is associative. However, we have subtraction here. So then we've got to remember that subtraction is defined as the addition of a negative. If we remember that, then we can rewrite this as C plus negative 3. Rewriting subtraction as addition is a blessing. It's very nice. It lets us do all sorts of things. And so we can make that step, rewriting that subtraction as the addition of a negative. I would just say definition of subtraction. That's what it is. We denote the additive inverse of a number A as negative A, and then we define the addition of negative A as subtracting A. It's a kind of roundabout way of describing something that seems instinctually very simple, but that's what's going on. This is the definition of subtraction, why we're able to do this. CC says, wow, that's great. Thank you for your enthusiasm, CC. I agree. It has been a lot of fun so far, and it's quite challenging. It's definitely more challenging than my last job, and I am enjoying that. I like a little bit of pressure, so it's good. Algebra 2 is my one course that isn't, like a moderately challenging course, but it still is challenging for various reasons. One of the big challenges is that Algebra 2 content, it's been so long since I did this stuff, and it's stuff that I've sort of been using for so long that it's quite difficult to get the perspective of a newcomer to Algebra 2. And so I kind of have to be wary of my language and how I describe things, because it's tough to know what's natural and what isn't, and what's tricky and what's not tricky. Like, it's just been beaten into me that fractions are the best. Why would I ever use decimal? I'll pretty much always use fractions. But not everybody feels that way, which is news to me. Who doesn't like fractions? Crazy. Okay, so then from here, now that we have addition, we can use associativity. Now we can associate the negative 3 with the positive 3. So instead of having C plus negative 3 in parentheses, I'm going to say let's put the negative 3 in parentheses with the positive 3. That's associativity. Addition is associative, so it doesn't matter how we group these things. Okay. Now we're there. Now we are there. By definition of this additive inverse, what does negative 3 mean? It's the thing that when we add to 3, we get 0. So if we add this, we get 0, and then, we could go really slow here. C plus 0, this is because we had an additive inverse, so I might just write add inverse, just as some sort of brief notation. And then, how do we know this is equal to C? Well, because we're adding 0, which is the additive identity. So I might just write add ID. The additive identity of 0, if you add it to anything, you're going to get the same thing back, which in this case is C. So C plus 0 is C. Bada bing, bada boom. That's how you prove this. And yeah, pretty slick. Just those properties of real numbers, and you can chug right on through some of this stuff. Just like I chugged through my sleepy time tea. If I had more energy to set up some of my technology tonight, maybe I would have worked on some math raps, but my patience is just not there tonight to wrestle with my technology to get it to work. So I just can't do it. These live streams are always stressful to set up. Okay. Should we do another example? I don't know. I think those examples are pretty illuminating. That's the general process. You want to think very slowly how you're going to combine the things you want to combine, and step by step how you're going to get there. Thinking very deliberately about each thing that you're doing with the expression. And I think those examples are pretty illuminating for the rest of the exercises that this wonderful Algebra 2 textbook asks of us. And once you get these real number operations and properties down, the world is your oyster, and hopefully you don't make a bunch of mistakes because you know how the real numbers work, and that's fantastic. So if you guys have any other questions besides this cool stuff, if you got like any graph theory questions or whatnot, you're welcome to shoot. I think I might poke my nose into a little bit of vectors just for a few minutes maybe. Let me tell you, I have a lot to review with my vector calculus, with my multivariable calculus, but I'm working through it. I am working through all of my review. I've got my giant copy of Stewart's Calculus here with me. My desk is just covered in math books. So many math books. Actually, instead of doing vectors, maybe I'll take a quick look at a calculus limit problem and see if it's not too late for me to hash that out. Just sort of playing around with these textbooks that I got. I want to get a feel for them. I want to get a feel for their exercises and get a feel for the stuff that I've forgotten. Avi So says, yes, let's do vectors. Okay, if you want to do vectors, I'll close my... I was just getting out calculus, graphical, numerical, and algebraic. But no, we can do a couple vectors. 2310 Sammy says, hey man. Hey 2310 Sammy, I hope you're doing well. Thanks for popping by. Let me know if you got any questions about anything. Alejandro, my boy, says, hey, I have to take a shower. I'll be back. All right, Alejandro, wash up quick. Look forward to having you back if I'm still here. I don't know how much longer I'll go. Depends how tired I get. 2310 Sammy says, hey man, how many hours do you study math a day? That's tough to answer. It kind of depends what you mean by study. When I was an actuary, the answer to that question might be like an hour or two per day. After work, I make dinner, I'm working on math videos, and you might count working on videos as studying math to a degree because there's an amount of study that goes into the preparation and kind of making sure that I've covered all my crossed all my T's and dotted all my I's when I'm making a lesson, that I've really covered everything about the material that I want to cover. I don't know if you'd consider that studying math or not. Usually near the end of the day, when I feel like I've got enough done, I'd crack open a math book for an hour and a half, 2 hours. Depends on the day. Nowadays, now as a teacher, I'm kind of talking about math all day, and studying math a lot when I get home, but it's like I'm not studying new math, you know? I'm reviewing the math that I have to teach, because a lot of it is just stuff I haven't done in a while. So, like, I do math, like, all day, and I study math still probably a couple hours a day, I might say. But I gotta say, there's definitely this sort of hole in my heart right now. Like I got my graph theory textbook here with me. I haven't opened this in a while because I ain't got time for graph theory right now. I'm not teaching graph theory, and it just hurts me. It's like, look at that graph theory textbook. A lot of people are subscribed to my channel just for graph theory. But I'm not a graph theory guy right now. That part of my life is behind me. And you have to accept that people change, and I don't do graph theory anymore. That's a joke, by the way. I'll do plenty more graph theory, but certainly not right now. So let me look. Vectors. I'm trying to think. I got a long block multivariable calculus lesson on Thursday, and so I'm trying to think what vector stuff are we going to talk about. 2310 Sammy says, thumbs up, LOL, nice. Thank you for the thumbs up, Sammy. I hope my... that's me. Studying math is tough, It's very tiring. And you can put so much time into studying math and, not even finish a single page. And there is no shame in that. Sometimes that's, the best, to really dig in and, wrestle with a proof on a single page can be quite illuminating. Sometimes that's the best way to spend an hour studying math. What's my favorite area of math? It's hard to say. I have a lot of love for different areas of math. Obviously, I love graph theory. Just in general, I like discrete math a lot. Set theory and graph theory and algorithms. I used to be really hot on probability theory. Not as much anymore. Just because I don't actively do it a lot. But I like probability theory. Game theory, I really like game theory. And I love calculus. There's so much beauty in calculus. But if you told me to pick a favorite, I'd probably have to say graph theory right now. I'd probably have to say graph theory. So obviously I'm not done with graph theory. There's lots more graph theory in my life, and lots more graph theory that will come to Wrath of Math. So for vectors, today I was just talking about scalars and vectors and introducing the sort of, component notation for vectors. So I think what I'm going to get to next is going to be dot products and unit vectors. Going to talk unit vectors as well. 2310 Sammy says, cool, with a smiley face. Thank you. Yeah, it's hard to say, and it depends when you ask me. But I would be interested in what your favorite area of math is, Sammy. If you got one, let me know. I'd be curious to know. I really like real analysis. Analysis is a lot of fun. But it's definitely not the subject of math that I've worked with the most. Probably financial math is what I've worked with the most, which I like that stuff, but it's definitely not my favorite. Definitely, at least in my experience, the most profitable. Which kind of makes sense. Depends what you're doing, though. So. Well, one of the things I love about vectors, I love the proof that vector addition is commutative. I just think it's a cute proof. If for anyone who doesn't know about vectors, vectors are really simple. It's just a thing that's got a direction and a magnitude. So this is an example of a vector. It's got a direction that's given to us sort of by the arrowhead. It tells us where the thing is pointing, and its length is the magnitude of the vector. So it's this thing that has magnitude and direction. We could call this vector v. We give it a little hat over the v to indicate that it's a vector. And then, just as another example of a vector, we could draw one like that and say that this is the vector u. Just like anything in math, we love to perform operations with these sort of objects that belong to the same class. These are both vectors, and in a way they describe motion. Like this vector describes an amount and a direction of motion from here to there. And the vector u describes an amount and direction of motion from here to there. And so we wonder, like, what would adding these vectors mean? And the way we add vectors is very cute. It's very cute how we add vectors. All you have to do, let's say we want to add v and u, the vector v plus u. You just line up u, which is the second vector in the addition, line up its initial point with the terminal point of v, and then just draw the vector from v to u. And that is v plus u, just like that. It makes this sort of triangle that's pretty cool. Let's see here. 2310 Sammy says, calculus, I love messing with limits and diffie-q. Complex analysis can be fun too. I hate real analysis though. I'm not the biggest fan of proofs. Yeah. Calculus is really cool. Limits, differential equations I have not worked with in such a long time. But I would love to work with those some more when I get the time to. Calculus is great, and I do love analysis. I love proofs, so, doing all those proofs in my real analysis playlist has been a lot of fun, and I'm looking forward to building up the real analysis playlist some more, but progress on that has kind of halted as I start this first year of teaching. So real analysis progress has been slow, but I don't know, maybe over summer break, I'll just bang out like 100 more real analysis lessons and have a really good meaty playlist. But even 100 more lessons, might get me like 2 more chapters into a typical textbook of real analysis, because I'm trying to cover everything pretty thoroughly. So I think I've got like 65 videos or something in my real analysis playlist right now. And aside from like skipping to continuity near the end of the playlist, because I just made a few videos about continuity, besides that, the 65 videos gets us all the way up to infinite series. Just introducing infinite series is where 65 videos gets us. And they don't even like start at the beginning. Like the first video in the playlist is about some absolute value stuff. There's still some videos that need to come before that I haven't made because I find introductory stuff like the most intimidating and challenging stuff to do. I think it's very hard to come up with good introductory material. When I'm making videos, I'm very much thinking about showing you something concrete, and some of these like introductory concepts that would illuminate where we're going in real analysis, those are just not the types of lessons I'm most comfortable making, so I've been putting them off. 231 Osami says, do you know any programming languages? Failed college and was majoring in math. I love math, but don't want to give it up. Not sure what you want to do, but you do want to get into technology. Yeah, I know Python. That's the one language I've worked in, aside from LaTeX, the formatting language that used to write really nice math documents. If you dropped out of college though and you were majoring in math, I don't know. If you still want to do math, my question would be, why did you drop it? Assuming that's what you said, if I'm understanding that correctly. It's hard, so like if you failed some courses, I don't know, maybe you need better study habits, or maybe, I don't know, maybe you had a bad teacher, maybe the courses are too tough right now and you got to spend some more time prepping and practicing more. But as far as what you would want to do, if you wanted to get into technology, I would not be the guy to ask. But computer science, that has plenty of good math-y stuff in it. But I'm not positive quite how much. There might be a sprinkling of math if you're like majoring in computer science, and mathy thinking, but I wouldn't bank on too much math. You know, you got your binary, some good number system stuff with comp sci. You got algorithms, a lot of good mathematical thinking, but you know, math can be pursued with great success outside of college as well. So don't let it discourage you. I got out of college as quick as I could with my bachelor's degree, and you know, I still study math every day because it's fun. So I like to learn more math. Osami says, I underperformed because I wasn't disciplined with studying. Yeah. Studying can be difficult. So if you don't have a disciplined, you know, study habit that gets you studying as much as you need to, that's what's going to happen. So, you know, maybe you got to build up better study habits. But it could be as well that just, you know, that sort of environment is not one that you thrive in. I know that I was kind of at my wit's end as far as constantly being given like loads of homework and studying and taking tests. It's like at a certain point, I just wanted to study the math that I felt like studying and not the math that other people told me to study. So I don't know. It's tough to know what you want to do, you know? I mean, I just quit my job a few months ago, so I understand the struggle. So I hope some of what I said was at least of some use. But good luck. It's tough to make the right call, you know? But the experience of changing careers for me has helped enlighten me that, you know, the world's your oyster. If you want to make a change, you can make a change and try something else and see how it suits you. But vector addition, as I was saying, is super cool. This is how we add vectors v and u. You line up the second vector at the end of the first vector, and then go from v to u. And that gives us our vector v plus u. But then, of course, we would be very interested in knowing if this operation is commutative. Does order matter? Is v plus u equal to u plus v? It'd be kind of nice if it was, because it's very nice when operations are commutative. And we can show that indeed it is just using a parallelogram, which is pretty cool. So how would we do that? Well, if we look at this sort of triangle that we've got, all you have to imagine is taking our vector u and shifting it down along the vector v. So if I do a sort of, all we're doing is this. We're going to drag it down like that, and in that way we'll create a parallelogram. So I'm going to copy, paste, and bring this u right down there. Let me get some of this junk out of there. All right, so there's our vector u. An important thing to remember about vectors is that their position isn't really important, especially when we're treating them like this. What defines a vector is its magnitude and direction. Lay Stereo Canasio says, oh, I know this. Thanks for popping by, Lay. What do you know? Do you know how vector addition is commutative? It's pretty cool, isn't it? I love it. Again, any folks in the stream here, let me know if you have any questions about whatever. Let me know. Maybe I can answer it. Maybe I won't. I probably won't go for too much longer because I'm losing my voice. Teaching is definitely getting my voice like back up to its strength because I'm talking all the time now. So hopefully that will help me, live stream a little bit better over time as well. But my voice doesn't have too much staying power because I went so long working as an actuary at home and not talking that much. So all we did, we said, here we have v plus u. To show that u plus v is the same thing, we'll drop u down here, right? And then we're going to do the same sort of thing with the vector v. Take v and slide it along u, and you can see how we're going to get a parallelogram. So I'm going to take v. I'm not going to take the label. I'm just going to take the vector, and I'm going to plop it down there. Now, if we zoom in here so we can sort of see this a little better, what we see is we've got a parallelogram, and by definition of how we just defined vector addition, you can see we've got u lined up with this vector v coming out of it, and if we then connect the tail to the terminal point, that is the sum of the vectors. So v plus u is traveling along v and then traveling along u. U plus v is traveling along u and then traveling along v. And we can see how either way the net result is the diagonal of the same parallelogram. And so vector addition is indeed commutative, which is pretty cool. I didn't do a good job circling that. Pretty neat. I love how you can make these triangles and parallelograms with vectors, and it actually helps teach you stuff. One of the things I got to touch on soon are unit vectors, in particular the standard basis vectors. So I'm just sort of reading here what Stewart's calculus has to say about them. What does it say about vectors? Properties of vectors, talks about scalars. So the standard basis vectors, yeah, they're super cool. Standard basis vectors give us another nice way to represent vectors. So if we represent a vector that goes 1 unit in the positive horizontal direction, that would look like this, 1, 0. And we have a special name for this vector in particular. We call it the vector I, and we might call it I hat. Put a little hat over it, and that's often used to indicate that a vector has a magnitude of 1. And of course, we could check that this vector has a magnitude of 1 using our handy-dandy magnitude formula. The magnitude of a vector is the square root of the sum of the squares of its components, which is just a result of the Pythagorean theorem. So the magnitude of this vector is the square root of the sum of the squares of its components, and in this case, that's just going to be 1. So this is a unit vector. It's got a magnitude or length of 1, and we have similar notation for the unit vector that has a magnitude of 1 in the positive vertical direction. The vector with a magnitude of 1 in the positive vertical direction is 0, 1. It looks like that in this sort of angle bracket notation. And we call this bad boy J. Just like that. J hat. That goes up 1 unit. And using these two unit vectors, we are able to define all vectors in the plane, which should make sense because, you know, a point in the plane is defined by some horizontal distance from the origin, an x-coordinate, and some vertical distance from the origin, a y-coordinate. In this case, the I vector gives us our horizontal distance, and the j vector gives us our vertical distance. 2310 Sammy says, we're only switch with 2D vectors, right? I'm not sure what you mean by where only switch with 2D vectors. Are you talking about like the commutativity of addition? If you're talking about that, that generalizes for higher dimensional vectors, but you'd have to clarify what you mean. And so, if we have a vector like in angle bracket notation, like 3, 7, we can represent that as a sum of these standard basis vectors I and j. I captures a horizontal shift of 1 in the positive direction. And so, since this vector has a horizontal shift of 3 in the positive direction, all we need are 3 copies of I. since J, Osami says, sorry, I meant sticking. Are we considering 3D vectors too? Well, one of the nice things in this, when we start talking about vectors like this, is that 3 dimensions aren't a whole lot different than 2 dimensions. They get different very quickly, but when we're just talking about this stuff, they're pretty similar. For the 3rd dimension, if we wanted to talk about these standard basis vectors in the 3rd dimension, then of course we'd have to pop on a z coordinate of 0 for I and j, because they're still just capturing a shift on the x-axis in the case of I, and on the y-axis in the case of j. And then we need a standard basis vector to capture a shift on the z-axis, which would be the k vector, which looks like that, 0, 0, 1. But if we just work with this bad boy here, like I was saying, this vector has a vertical shift of 7. I say vertical shift thinking of like a particle moving along a vector. So the vector tells us how that particle is moving. It's going 3 horizontal units to the right and 7 units up. So then to capture that 7 units up that it's going, we need 7 copies of j. And so we would just write plus 7j. And that's a nice way that we can represent vectors. You can represent them like that with the angle brackets, or you can represent them like that with the standard basis vectors. It's important to note that in either representation, we're talking about position vectors, which have an initial point at the origin. So if we wanted to graph that guy on a plane, we could do that. Imagine that says, I never thought I would end up here, LOL. Imagine that. Why did you end up here? Why did you not imagine that, or why did you not think that you would end up here? Why are you here? Let me know if you have any questions. We'll probably wrap things up pretty soon here. I'm just sort of blabbing about vectors just to kind of practice my explanation, see what the textbook says about these vectors. Alejandro says, I'm back, clean and ready. Alejandro, I'm glad I'm still here for you. I'll probably be wrapping up pretty quick because I'm losing my voice. But I'm glad. I hope you had a good shower. I'm glad you're here. Let me know if you got any questions about anything. It's been a long time, since I did one of these live streams. Joshua Bowden says, yo, Sean, good to have the live streams back. Don't get too excited, Joshua. It's good to have you back in the stream. This was a sort of last-minute stream. I'm sorry that you can't hear the music. Not everything is quite as it usually is. As soon as I started this stream, some of my stuff got disconnected, and so I can't access all my files right now. I don't know how many, how regular my live streams are going to be. I'm adjusting to a new job, but live streaming is fun, but it's also it has its pros and cons. I've talked about it before. It can be kind of addictive, and it hurts my sleep, but it's fun. It's fun. Let's see. But I'm glad to be back, Joshua. Let me know if you got any questions or anything. Always happy to see familiar faces. Abby So says, could you please teach velocity vectors? I struggle to understand them a bit. I could make a lesson sometime maybe about velocity vectors. You have to understand anytime we're talking about math, calculus stuff, it's got a lot of great real world applications, but my bias is strongly towards abstraction. So I don't really have an internal curiosity about real world applications. I just like to learn the math in abstraction. But yeah, velocity, the difference between velocity and speed is what we would call a scalar, sort of just describing your rate of motion. But velocity captures your direction too. So velocity is your speed, which is a magnitude, and it's your direction. But what else more we could say about speed vectors? I'd have to kind of plan a lesson about it. Imagine That says on my recommended, and I just decided to click it, and I didn't realize I was subbed. Imagine That. You must have subscribed for some. I don't know why you subscribed. Maybe you saw the. Maybe you saw my calculator documentary, and you subscribed when you saw that. If you haven't seen my calculator documentary, I strongly recommend you do that. Maybe after I stop the stream, you could go check it out. Just type in TI 108 and you'll find it. Alejandro RZ says, are you already vaccinated? I hope you're doing well with all this. Thank you, Alejandro. I got vaccinated last month, I think. I hope you all are staying healthy as well. I hope things are coming to an end, maybe within the next year with any luck. Thankfully, I think, the outlook has been pretty good for most places these days. I know all the places I've been at have been doing pretty well, so that's good. I hope the same is true where you are, and if not, I hope things get better soon. But yeah, I was vaccinated in like mid-August, I think. It was such a hot day, and the day after I got vaccinated, I just laid in bed like all day basically. I've not felt like that in so long, and it was terrible. I just hated being such an unproductive slug the whole day. But, what are you going to do? Let me know if you guys have any last minute questions here before I wrap up. I'll just, for kicks, go ahead and graph this vector. Draw that Cartesian plane. Got our x, we got our y. But, I don't know, it's possible as time goes on that I might do more live streams to sort of quickly just put out some explanations about things that I'm teaching in my classes, but we'll see. Sometimes I feel like my explanations on live streams are like my worst explanations. I don't know why, but it's something about like I'm trying to look at the camera, I'm trying to work on my iPad, I'm trying to monitor chat. There's just a lot of stuff going on. But anyway, let's just draw this vector and call it good. 3i plus 7j. So, if we say we've got 3 of these i's, each I is a horizontal shift of 1 in the positive direction. So if we have 3 i's, it's like we're going forward once, forward again, forward a third time, and then we've got 7 j's, and j is our y component vector. So then we're going up 1, try to draw it, 1, 2, 3, 4, 5, 6, 7, just like that. And so our beautiful vector 3i plus 7j looks just like that. So, it couldn't really be any easier. A lot of this vector stuff, when we start off, it's really straightforward. If you have a component vector, A, B, C, so say a vector in 3-dimensional space, to represent it with those standard basis vectors, you're going to need A copies of I, B copies of J, and C copies of K. And pretty easy to graph in 2D, not quite as easy to graph in 3D, so we'll stop it there. Let's see. Joshua Bowden says, new glasses. These are not new glasses. I got these in 2019. I've got, like another pair of glasses I occasionally wear that are like blue light glasses, but these are my standard regulation daily wearing glasses. I'd like to get some new glasses because my prescription is kind of going, I would like a fresh prescription because my eyesight just keeps getting worse and worse. But yeah, last time I did one of these streams was in May, so it's good to pop by and chat with you all a little bit. Quieter night tonight, so hopefully next time I stream can see a few more folks. Last time I streamed was when I kind of was getting started working on my calculator documentary, which that was the most intense thing that I've ever done. That took so much work. If you guys have not seen that calculator video, please watch it. The calculator from your childhood. It took so much work, and it didn't perform nearly as well as I would have loved it to, but it performed about as well as I would expect it to. It's a very niche video, and I don't know, YouTube just doesn't really do a good job recommending my videos, certainly not right when they come out. If they ever do well, it takes them a little while. Part of that, I've talked about it before, it's just kind of the issue of a math channel like this. Same sort of thing with Khan Academy. The people who subscribed because I helped them out in like algebra class, we're not jonesing for a calculator documentary to drop. Joshua Bowden says it was totally worth watching. Thank you, Joshua. I worked so hard on that, and when I was pretty much done, there was time where I was like, I don't even need to post this. I was just so creatively satisfied with the project. It was just so much fun to work on. And one day, if the world is just, then one day that video will get to 1 million views. But it's fine if it doesn't, because I'm just so happy I made it, because it was so much fun and a really great challenge. Shadow No Chase says hello. Hello, Shadow No Chase. I'm going to be wrapping things up here pretty quickly. Let me know if you have any quick questions before I go. Alejandro RZ says, oh yeah, the people from Texas Instruments watched your video. Achievement unlocked. I know. I was so hyped that Texas Instruments watched the video. They DM'd me on Twitter, which is like, the coolest moment of my life was Texas Instruments DMing me on Twitter. And they said, hey, what's your address? We're going to ship you something. And I gave them my address. I was so excited. I was so excited when Texas Instruments messaged me asking for my address that I discovered my phone has a flashlight, a shake to turn on flashlight feature. Because I shook my phone just based on my excitement, and my flashlight turned on. But alas, wouldn't you have loved to see the unboxing video of whatever Texas Instruments was going to send me? I was so excited. They never sent me anything, which really bummed me out. I don't know why. I didn't feel like nagging them, because I didn't want to be like, hey, where's my free stuff? Where's the free stuff you said you were going to send me? My only guess is that, the social media team or the social media guy just gave it a quick check with, upper management. Hey, can we send this dude a thing? And maybe they glanced at the documentary and didn't like some of the negative stuff I said. I don't know. I mean, just to make a sort of compelling story, I tried to kind of paint the Texas Instruments 84 Plus as the sort of antagonist of the story, just to get a little drama in there. But, well, they didn't send me anything. Maybe the next calculator documentary, they'll send me something. CC says, you need more clickbait, math clickbait. Yeah, I know. It's I don't know. The videos I enjoy making most, generally speaking, are just normal videos. I like to talk about various proofs. I like to do a good job explaining mathematical concepts. The clickbait has worked more or less in the past. Not clickbait, but I don't know, the more clickable titles and stuff. It works okay, but I don't know. I don't know, man, I've had ideas that are more math clickbaity videos, but I'm not always in the mood to make those. Shadow No Chase says, just came in to say hello. A long time ago I came in here and remember discussing graph and Ramsey theory. Yeah, a lot of people, I don't know if maybe even most people that are subscribed to my channel subscribe for graph theory. I definitely plan on making videos about Ramsey theory at some point. I think Ramsey theory is super, super cool. So I'll make some videos on that at some point. I still have so many graph theory videos I'm excited to make. For math clickbait stuff, I'd like to make more math raps, but the thing is, I still have fun writing the math raps, but recording them, it's I don't feel like recording the math raps, and it just takes such a sort of positive energy to do that, that I don't always have. Alejandro says, maybe Hewlett Packard stole your gift. Maybe. I tell you, I researched so much for that documentary, and the HP 65, what a nuts calculator. If I had to make a documentary on another calculator, it would probably be the HP 65. And in my math classes, they've got all these calculators, and I just feel totally lost because I can't use any of them. I'm like, there's no TI 108s in here, and there's no TI 30XS multi-view, and there's no BA2 Plus. And those are like the only calculators I know how to use. And so I keep forgetting to bring my calculators that I'm comfortable with in with me. But one of these days I'll remember. Shadow Noche says, did you do any grad school maths? No, I never went to grad school. I've just studied a lot of math since graduating with a bachelor's. A lot of time, I'm just reviewing stuff from my bachelor's degree because, learning it once was one thing, but sort of studying it all again independently is a really, for me, a much more enlightening experience. I found that to work better for me. No, I've just been studying math independently since I graduated with my bachelor's. Alejandro RZ says, corrects himself to Hewlett. Yeah, Hewlett Packard. Crazy calculators. All right, folks, I am going to pack it in for the night. Nice doing a little bit of math, having a little bit of chat. Hope to see you again next time I pop on for a live stream. I don't know when that will be. Sometimes the mood just strikes me. Maybe it'll be another 6 months, but hopefully not. I think it's a good way for me to sort of hop on and practice talking about some of the stuff that I have to talk about. There's a lot I have to talk about. So, Shadow Noche says, what were your favorite math classes? In college, my favorite math classes were my introductory proofs course, abstract algebra, real analysis probably. Those might have been my top three: abstract algebra, real analysis, and my logic and proofs course. Logic and proofs is where I really realized that I loved math. I was like, this stuff is the best, I really loved the rigor of logic and proofs, which I hadn't really seen before. CC says, see you later. Ciao. Ciao to all of you. See you later. Yeah, looking forward to making some more math videos when I have the time, but the output has significantly diminished because I have much less time, which might mean that I do more live streams just to sort of get some content out, but we'll see. Let me guys know, as always, if you have any video requests. I'm always working on stuff, even if you don't see anything. I've been working on a rap from the perspective of the TI 108 calculator. I don't know if I'm ever gonna post it, but it's fun, so I do it. I do it for kicks. Shadow Noche says, was your intro to proofs through geometry or number theory? It was number theory stuff. I mean, technically speaking, my first introduction to proofs was in high school geometry, but my college intro to proofs course, which is what I was talking about, was your typical sort of number theory-ish proofs course. Yes. Have a good night, guys. I'd leave you with some music, but my music isn't working. So there's no music. You can just sit in silence for a couple minutes while I stop the stream. All right, folks. Good night. Thanks for coming.